to the computer. Okay, so we're coming into our assignment for today. Opening up that review that we worked on for homework last night. Okay, I'm going to pull up the chit chat. I'm going to view it as a student, and let's take a look. So first thing I'm going to do is I'm going to zoom this guy out. And let me show you some strategies that we can use for solving this guy here. So we're looking at this guy here. It tells us a couple things. It says a square weighs 4 grams. And I have to go one more. A square weighs 4 grams and a circle weighs 6 grams. We need to figure out how much a triangle weighs. Okay, I'm gonna write some things on the board. I'm gonna say a square. Whoa. Okay. I'm gonna do it with the thing because it's gonna cook the wrong spot anyways. Give me one moment, my friends. Boom. Okay, let me close that guy out. Okay, so we know that 2 things. We know squares equal 4, circles equal 6. I need to figure out my triangle equals like something that we don't know. Question mark. Okay. So when you were looking to figure out what the triangle was, there was really a couple ways that you could do this. What were you thinking for your first attempt on this? Looking at this, what do you think you're going to do first here? Avery.
On the left side, like add up all the numbers.
Okay, so we could go through and we could say all of these squares are worth 4. Right? We could say all these are worth 6. Is there something else that we could do here? And then we could say, like, we don't know what these are, so we could call them X's. Alyssa Button says, let's see what Alyssa Button says. Alyssa Button says we can eliminate squares and circles from each side. Can we eliminate some pieces from each side? And what do they have when we take pieces away? So like if I were to take away a circle, what has to be true about the other side, Olivia?
Another circle would have to be taken away as well.
Very good. So both you can take away like terms from each side, right? So if I get rid of a circle here, I can get rid of a circle here. If I get rid of a circle here, I would have to get rid of one on the right-hand side. Let me show you. Actually, I should have done this from the beginning. So if you wanted to do this out, let me show you. You hit this up at the top here. There's like a little notepad, and it lets you write on here. Okay, so you hit the little sketch pad, and if you hit the pencil, you can write on here. Let me show you. So you can cancel out your like terms here. Cancel them out. What else can I cancel on each side? Is there anything else that I can cancel? Avery?
2 squares.
Squares. 1, 1, 1, 1. Is there anything else that I can cancel? No, because I have only squares left on my left, and there's no more squares that I can cancel out here. So now I can go through and do exactly what Avery said and label what we know. It's easier if we just label what we have left. What am I going to label the squares here? How much are they each? 4. Okay, what are we going to label our triangles? We don't know what they are, so we call them X. Very good. And I'm just going to put a little X over them. Okay, so I have some X's, I have some values. What can I create here? Remember, these hangers represent our balance, right? So we can set one side what to the other side. We can say that each side is what to each other because it's flat on top. Equal, right? So we can create an equation. How much do we have on the left-hand side here? Brandon? I have 4 and 4. Oh, so total it would be 28, but we canceled out those like terms. So we're just going to look at what we have left here. How much would I have if I just look at what I have left? 8, very good. I could say 8 is equal to, what do I have on my right-hand side? I just have what left? Ethan?
Oh, 4 triangles.
4 triangles, which we said were x. So we could write that as 4x. Nice job, Ethan. So I know that if I have 4 triangles weigh 8. How can I get what a single triangle is going to weigh? What do you think, Avery?
You divide 4 by the 8, 40.
Very good. We divide by 4 on each side. To get a single x, divide by 4 on each side. I'm going to get an x is equal to 2. Okay? So let me tell you what we're going to do for tomorrow. Okay? So tomorrow you're going to have another question that looks similar to this, where you're going to need to figure out what one of these shapes is worth and what it weighs. I'm going to give you this same picture from the assessment on a slideshow so that you can put the X's and label things on there, or you can use the pencil tool and do it in the assessment. Both spots can work. And you're going to have space to do this workout as well, okay? In case you don't feel comfortable using the writing tool, like how we did it in class, okay? So we got X is equal to 2, so I'm going to come down below here, and then I'm going to select my X is equal to 2. Close this guy out. X is equal to 2 grams. Jonah? Oh, question?
No.
No, okay. How do you feel with this guy here? Feeling okay? So my suggestion, you could have created an equation. You could have said 28 is equal to 4x plus 8. 20. You could have said 28 is equal to 4x plus 20 and then solved it that way. But it's easier if you cancel out those like terms on each side and then sort of go from there. Okay? Because then it'll get you the same answer if you do it either way. Perfect. Let's look at number 2. I'm going to zoom it back in. Give me 1 second. Okay, we have to talk about on this one here, it's asking us about the number of solutions. Okay? And what are our options? When we're talking about number of solutions, we have 3 options for the number of solutions. What's one of them, Tiana? No solution. What do we know that looks like? We talked about this yesterday. What did it look like when you were looking at equations? I mean, like when you were looking at equations like this. What did we notice about the slope? What did we notice about our constants? No solutions means they have what in regards to the slopes? Olivia?
No slope.
What do we think? No slope? No slope is when it is a horizontal line. I'm looking at these. They have the same, they have slopes. It's not about not having a slope. No solutions have the same slope. And what about their constants? Avery. Same slope. Different constants. Okay? When we're talking about number of solutions, we look at slopes and constants. No solutions has same slope, different constants. What's another option for a number of solutions? Avery? Infinitely many solutions. Very good. Infinitely many solutions. What do we know about the slope and constants of those ones? Carter. Infinitely many solutions. What do we know about the slopes? Slopes are?
What's the word?
It's very not complicated.
On the tip of my.
What about the constants?
They're
Use these words. Look at these words that I used up here. The slopes are
Oh, different.
infinitely many solutions have different slopes.
No.
Infinitely many solutions have the same slope. And what about this? What about the constants, Tiana? Same constants as well. Very good. And then what's that last type of solution that I could have? No solutions, infinitely many solutions, and Jonah?
One solution.
One solution. Very good. Hey, Bridget, how you doing over there, my friend? I haven't heard from you yet today. I'm just wondering. What do we know about our slopes and our constants for one solution? Avery?
Different slopes.
What about the slopes?
Different slopes.
Different slopes. Very good. Very good. We know that one solution has different slopes. Very good. So, that being said, let's look at some of these systems that we have here.
Same constants.
Same constants, but what do we notice about those slopes in that first one? Different slopes. So, Billy, if they have different slopes, how many solutions is it going to have?
No solution. One solution.
One solution, because when you have no solutions is the same slope, infinitely many is the same slope. One solution is different slopes. Good. Right away. Now let's look at that second one. What do we notice about that one? Olivia?
It has the same slopes.
Has the same slopes. Good. So it could be infinitely or no solutions. Now we need to look where to make that final decision, Isabella.
With the constant.
At our constants. Fantastic. What do we notice about those constants, guys? They're different. So how many solutions is this guy going to have? No solutions. Bonus question, Brandon. When we look at it on a graph, if it has no solutions, what do we know about those two lines?
They're parallel to each other.
They're parallel to each other. They're never going to cross. You missed it. I just did an epic high five, Brandon. Good job. Anyways, wasn't as epic. Okay, now, this is where it gets a little bit trickier. Okay? When we look at the third one, first, what do you notice? Just looking at it, what do you notice about that system there? Tiana, what do you notice? Oh, there's two different, not numbers, but two different letters, variables. Very good. There's two variables, or the two variables are on the same side. Good. What else do we notice? Olivia?
There's no like y equals and x equals in the beginning of it.
Good. So they're not written in y equals or x equals. So it might be a little bit tricky when we go to figure out the number of solutions. Interesting. What else do we notice looking at these guys? We have single x's in the first one. We have 2x and 2y in the second one. What did we do yesterday in order to get them to have the same number? Like the x's and the y's have the same number in front. What did we do? Avery? We distributed. We multiplied by some sort of number, right? Because we want to get our x's here in the first one, x and y, to have the same number in front. So what would I have to multiply or distribute to this equation to get it to be a 2x and a 2y? X times what number is going to get me a 2x? Avery? 2. So I need to multiply this equation by 2. 2. I need to distribute to all three pieces. 2 times x is going to get me 2x. 2 times y plus 2y is equal to 60. Yes. When I compare the second one and my new one, what do we notice?
Same slope, same constant.
Same slope, same constant, the numbers in front of the variables are the same. So what do we think, using this idea of these different solutions here, we haven't explicitly talked too much about this one, what might you think the solution might be for this one here? Olivia, what were you thinking?
Infinitely many solutions.
And why do you think that?
Because it has the same slope and the same constant.
Very good. Our constant is the same, 60. And those numbers, those variables, those slopes are the same. Very good. So this one would be infinitely many solutions. Very good. Nice job. Last one, this last guy down here. First, I'm going to ask the same question I always ask first. What do you notice about this guy here? What do you notice? Anything at all? Jonah?
There's no x equals, but there's a y equals.
Okay, so this second one is written as y equals. Okay, good. What else? Go ahead.
The equation is flipped around the bottom one. It's like the equal signs on first and not second.
Good. So it's not x and y's aren't on the same side. They're separate sides. Good. Anything else that we notice? Tiana? There's no other numbers besides the 10. Good. Bridget said that one of the x's is negative. Good. So if I look at this equation here, the first one, x plus y is equal to 10. I want to do something to this equation to get my y by itself. So if I want to move that x over to the other side, what are the two operations that I can use to move an x? What and what? Avery? There's no parentheses, so I can't distribute. I can move an x all together over to the other side by either doing what or what? Tiana? Exactly. So let me give you an example. I have 2x plus y is equal to 10. I want to move this whole 2x over to the other side. So remember, to move a whole piece together, you have to either add it or subtract it. I don't know why I just wrote a y. Add it or subtract it. So I'm going to move this 2x over by subtracting it. I'm going to do the same thing over here. Subtract an x on each side. I'm going to be left with y is equal to what? Avery? 10, not 10x, 10, what was it? Not 10x, minus x. Sorry, is that what you said? I'm sorry, my ears are a little bit, one of them stopped up today. So, I reworked this guy so that the y is all by itself. When I compare it back to the second equation here, what do we notice about them? What do we notice about our slopes? That number attached to our x. Olivia.
That they're different? No, that they're the same.
No, sort of.
Welcome, Diego. That's okay, Diego. They are the same, right? We have a negative x and a negative x. We have a plus 10 and a plus 10. So if the equations are exactly the same after we do a little bit of work, how many solutions is it going to have? Infinitely many solutions. Very good. Boom. Listen, I understand that this guy was a little bit tricky. We're going to try our best. I might be able to give you a couple pointers tomorrow when we're working. So please remember, as we're going through, if you have questions, you're asking them, okay? And even tomorrow when you're working on it. That's okay, Diego. I know I already answered that statement, but I wanted to just acknowledge it again. Please make sure that if you did not complete this, you are completing it now. This is super duper duper important. Remembering that all of my assessment things, like the reviews, are worth grades. So make sure you're filling it in. I need to solve this system. Solve this system of equations. First question, what do we notice about this system? Anything at all? What do we notice? Olivia?
For the 2x plus y equals 10, there's no like y equals in front of it or x equals.
Okay, so this one is not y equals, okay? And what do we do when I ask you to solve a system? What do we always do with one of our equations? Olivia?
Put it in parentheses.
Take one of the pieces from one of the equations and we do what with it? We put it in parentheses and we do what with it? Plug it in, yes. So which one of these equations, looking at it, is simpler? Tiana, the second one, because it's written as y equals, right? We look for the equations that are written y equals, and we take the far side of it, and we do what with that whole piece? We plug it in. Yes, Jonah. For where in the first equation?
For the y.
For the y. Okay, tomorrow, here's the deal. You're going to have a solving box on the slides. So I'm writing these steps out now. Tomorrow, you're going to have a space to do all this work out in. So if you don't want to write this all down right now, you don't have to. You will have a space to organize tomorrow. Solve for x, solve y. Okay, so we said already that we're going to plug it into that first equation. 2x plus y is equal to 10. That's the one we're plugging it into. Now, we need to take that 4x minus 2 and plug it in. How would I rewrite it after I plug it in? Lily, what do we think here? How would I rewrite it? Instead of saying 2x plus y, I'm going to say 2x plus what?
4x minus 2.
Very good. Plus 4x minus 2 is equal to what? I'm going to put it in parentheses. Yes, right. Sorry. Is equal to how much? 10. Yes, Tiana. So I just took this y, I took it out, and I plugged in that 4x minus 2. Okay? Now, what's my next step here? Carter, what do you think?
It'd be 2 do 4x minus 2.
So you could rewrite it as, how could you say it again?
You do 4x minus 2 and you write it as, I believe it'd be 2x plus 2x equals 10.
We're not going to distribute here. Is that what you're trying to say? Distribute that 2x? Nope, because it's a plus sign, because there's a plus sign in between.
Right.
So it's really just saying 2x plus what? Olivia?
2x plus 4x
Yeah. Bring down the
minus 2.
minus 2 is equal to how much? 10. Now, there's 2 steps that you could do first here. You can move your constant, or you can combine your like terms. What do we want to do? Olivia?
Combine the terms.
Okay, so we're going to combine them. What are we going to combine here? Annie, what do you notice that we have 2 of here on the same side? And a 4x, right? So I have a 2x and I have a 4x. How many x's do I have altogether? Bam! Yes, Annie. 6x. What? Avery?
Equals 10.
Ooh, don't forget your
My bad. Minus 2.
minus 2 is equal to 10. Very good. What's my next move to get my x by itself? Ethan, what do you think? I have a 6x minus 2 is equal to 10. I want to get the x by itself. So I need to move that constant. How am I going to move it?
You have to get rid of the 6.
Can't do that. We have to get rid of the constant first.
Okay, so then you would,
It's a minus 2. How do I move it over to the other side?
you'd have to get rid of it,
By doing what?
adding it.
Yes, very good. We do the opposite. Woo, woo. That's a backwards, by the way. By adding 2 to each side. Very awesome job, Ethan. Fantastic. I'm left with what on my left-hand side? Avery?
6x.
Oh, give me 1 second, Jaden. 6x is equal to 12. Hold that for 1 second. Let me see what Jaden's question is. Because in another problem, you would have to distribute first, Jaden. So sometimes you have like 2x plus 2y is equal to 10. And then you would have to distribute the 2 to each of the pieces inside there first. 4x minus 2. So the reason that we can take the parentheses away is because it's not as difficult. We don't have to distribute before we combine. Good question there, Jaden. Oh, perfect. Okay. So I have 6x is equal to 12. I'm done.
No.
What do I got to do, Tiana?
You have to put the things in the solution.
Yep, so I have to get my x by itself. So what's my next move going to be? Division, yes. And what am I going to divide by? We want to get the x by itself. 6, because the 6 is attached to the x through multiplication. So I have to undo it by dividing by 6. Divide by 6. I get x is equal to how much? Yes, Lily. It's equal to 2. Now I'm done.
No.
Oh, I need to calculate my y. Oh, this is so many steps.
I know, right?
Which one of the equations are you going to use to solve for y? Both will work. Billy, which one do you think we should use? Which one's simpler? The 2x plus y equals 10?
No.
We're solving for y.
It would be the y would be
Good. Y equals 4x minus 2. I have to plug in now. Carter, what am I plugging in for my x value here? When I rewrite it, it's going to be? No, I don't. Okay, so yeah, we're plugging in 2. So how would I rewrite the right-hand side here? Y is equal to?
2x. Or just 2.
You're leaving pieces out. Read the original equation to me.
4x minus 2.
Okay. So what is that 4? How is that 4 attached to the x? There's no symbol there, Carter. So what operation is holding that 4 to that x?
Oh, multiplication.
Good. So you can't lose that 4, Carter. It's going to be 4, and instead of the x, you're going to write what?
Times for the multiplication. Oh, yeah, that.
And then what is your x value?
2.
You're going to plug it in. So it's going to say y is equal to what?
4 times 2.
4 times 2. And what else do I need to bring down?
The x.
We already got rid of the x by plugging in this 2. Y equals 4 times 2.
Y.
We already have a y.
Yeah. Oh, the other 2.
And what are we doing with that 2?
We'll bring it down.
But what is that 2 going to be? 4 times 2, what? Jonah? Minus 2. So what you do here, when you're solving for y, you pick one of your equations. And you plug that value in for x that you just calculated. Y is equal to 4 times 2 minus 2. What's my first step here, Avery?
multiply the 4 by 2 parentheses.
Y is equal to?
8 minus 2.
Y is equal to how much?
6.
Very good. Fantastic job. Fantastic job, Carter. Awesome job sticking with it. I appreciate it. Now I need to write my final solution. What am I going to get here, Avery, as a final solution?
I actually have a question.
Oh, sure. Go ahead.
So it doesn't really matter which equation you pick.
No, if you plug it into either one, it's still going to get you a y of 6. But the only reason I say plug it into one that has like a single variable is equal, because if you plug it in here, 2x well, 2 times 2 plus y is equal to 10. We would have to do 4 plus y. And then we'd have to subtract 4. We'd have to remember to subtract your 4. And we get y equals 6. But it's just a little bit more complicated because you have to isolate and get your y by itself. So I always say choose the one that's like y equals or x is equals, because then you won't have to move things around. You'll just have to plug it in and solve. This one or that one is way more difficult, way more easy than this one here. What's my final solution? Olivia?
2,6.
Very good. 2,6. Very good. Nice job. And then for the show or explain your work, if you do the work on the slides, I would just write C slides, because that's all I look for. And then I'll look at the slides and see that you did the work. If you want to do it on paper and insert your picture that way, please feel free to do that. When we did it, we like typed them out, but you can write them out if you'd like. Carter, do you see how we did that, buddy? You see how we did that? Okay. Here we go. Now, number 4, you're going to be given a system of equations. You're going to be asked to talk about the number of solutions. It's never, when you're looking at this tomorrow, it's not going to be no solutions. It's not going to be infinitely many solutions. We're going to have to decide which one of the 2 coordinate pairs we give you makes it a solution. So Billy.
When is our math break?
We're going to go down. I need to get through some more of this though. I need to get through this, or else we're not going to be ready for the test tomorrow. So we're going to try to go down at the end, but we got to get through at least 3 more questions. So we got to work a little bit quicker. What is it? So there's it. Thank you, Billy. Just got me completely off track, buddy. So it's not going to be no solutions. It's not going to be infinitely many solutions. It's going to be one of these 2 coordinate pairs here. We have to plug this coordinate pair or these both coordinate pairs in to the equations and see, does it make a true answer? If I were to take this first equation here, y equals 3x plus 18, I'm really terrible. Plug in my x and y values. How could I rewrite this? What's my y value? Isabella. Looking at this ordered pair here, we're going to plug it in. What's my y value in that ordered pair?
-30.
-30 is equal to what?
3 times
-16 plus 18. Now I'm going to do that math out. Like I said, I'm going to go a little bit faster because I got to get through a couple more of these. -30 is equal to 3 times -16 is -48 plus 18. -48 plus 18 gets me a -30 is equal to -30. Is that true? -30 equal to -30. Is -30 equal to -30?
No.
Yes, it is. So this is going to be the solution here. If you plug it in and it's not true, 15 is equal to 20, that's not going to be the solution. That's not going to be the one that you choose. So make sure that tomorrow when you're looking at these, you're plugging these ordered pairs in. Does it make a true solution, yes or no? Okay. Let's look at number 5 now. Number 5 is probably the most, I like this one the most. It's a little bit challenging though. So let's take a look. You hate it?
Yeah, this one was very difficult.
Come on, this is my favorite.
That's your word problem.
You're crazy.
I'm crazy? Okay, Miss
You
Albert.
met her, right?
And I know you met me, right? Because I am crazy. Miss Albert and Miss Jermaine, I'm saving money. Me and Miss Albert were saving money. Miss Albert starts with $50 in her bank account and adds $10 per week. Miss Jermaine starts with $20 in her bank account and adds $20 per week. after the first week, how much is Miss Albert going to have here? Carter.
$120.
Miss Albert, after 1 week, is going to have $120. How did you calculate that, Carter?
I did 50 plus, or I started off with 10 and then I multiplied it by 7 because that's how many days there are in a week.
Oh, but it doesn't add $10 per day. It adds $10 per week.
Oh.
Trickster. So it's
What's the
not,
correct answer though?
So then it'd be 60.
it's going to be 60. Very good. Good correction there, Carter. Make sure you're looking at these really closely. You're saying after the first week, it adds $10 a week. The 50 original plus the 10 for that first week is going to be $60. You're going to come in that box. You're going to just type that number in. Do not type $60. Just type in the 60. Let me show you. You're going to come in here. You're just going to type in your 60. Boom. Now, how much is Miss Germain going to have in her bank account? Olivia,
$40.
how did you get that?
20 plus 20 plus 40.
Very good. The $20 originally plus the $20 for that first week is going to be $40. Boom. Nailed it. Next piece, we need to write an equation for Miss Albert for the amount of money that she's adding each week. Remember, we write equations in the form y equals mx plus b. What does the m represent?
Wait, money.
Tiana,
Money?
huh?
Money?
Money, right? M is our, we're looking at more broad though. Avery? Nope, that's our B. Y is our slope. Or our rate of change. We have been doing this for 2 units now. You guys need to know this. This is something you guys should have down. This is the 3rd unit that we've done this in. We've started it at the end of unit 2, all of unit 3, now in unit 4. Y equals mx plus b, m representing your slope. B representing what? Our constant, good. Or our what? Right, our initial start value, our y-intercept. Y-intercept. Okay? Let's write an equation for Miss Albert. We start with y equals what? Olivia.
50? Yeah, plus 10.
What do we think? 50 is our constant rate of change. 50 is how much she is adding every week.
Oh, no. 10 is how much she's adding every week.
So the equation would be written what? Your constant rate of change, how much you're adding every week, is you're going to be that letter. Help me out, Carter.
It'd be y equals 10x.
Nice job, Elizabeth. 10x, I missed the second part.
Plus 50.
Plus 50. Do not just take them in the order they're given to you. You need to think strategically. That 50 represents how much she started with. Our y-intercept. She's adding $10 per week. That means it's going to be your constant rate of change. You're going to come in this box right here. You're going to type in. I don't know why Aaliyah is coming in and out the whole time. I don't understand.
She could be having connection problems. It sometimes happens to me.
Y equals 10x plus 50. Aaliyah, how you doing, buddy? I see that you're coming in and out. Are you having internet problems? What's going on? Let me know in the chat, please. Nice job. What's my equation? Lily, what's my equation gonna be?
Y equals x.
Good. My rate of change is $20 per week, plus the original 20 that I started with in my account. Very good. Now I need to graph this guy. We're gonna scroll it down. Let's take a look. This is gonna be done tomorrow on the slides. I'm not gonna have you do it in this program here, so let's just take a look at the graph together, okay? So I'm not gonna have you guys do it on yours. I'm just gonna go through it here. You're gonna help me to graph it. Okay, Miss Albert's line, I'm gonna do in red. Where does Miss Albert start on my y-axis? Carter.
50.
Good. And then every week, Jonah, how much does she add to her bank? $10. So if I want to extend my line, what am I going to do? Rise over run. Olivia.
We're gonna go one to the right and then one up.
Very good, because each one of these boxes represents how much money? $10. Good. So we're going to go over one, up one as well. How do I extend it again? Avery?
Over one, up one.
Very good. Over one, up one. And what do I do to those lines? Connect them. Tomorrow on the assessment, let me tell you what it's going to look like. This one is going to be on slides. This picture is going to be on the slides. I'm going to have a stack of points like we have always done. You're going to move your points on where they go, and you're going to connect them with the lines that are on the slideshow for you. I'm going to go through it again tomorrow when we see it during the assessment. Good. Now, when you want to graph my end, where do I start on my y-axis? Olivia? 20. What's my rate of change? Tiana? Up to over one, because I have $20 per experience, right? Every week. So up 2 boxes over one, up 1, up 2 over 1, up 2 over 1, like this. Okay? So then if we look at, I'm not going to scroll it because I want to keep this graph here. If we look at question number 4, E, after 4 weeks, who will have more money in their account? It's going to be me, Miss Jermaine. We're going to do E, Miss Jermaine. For F, it says after how many weeks will they have the same amount in their Avery?
3.
How did you know that?
Because they intersect with the mark.
Very good. To find out when they will have the same amount of money, you have to find that intersection point. How many weeks? 3 weeks. Okay. Once again, I didn't move it so that you could still see this, the graph here. So you're going to have to scroll down to do at E and F. Okay. Ladies and gentlemen. Okay. So I didn't get a chance to get through as much as I did with the last period. So what we're going to do, I am going to, at the end of the day today, I am going to record a screencastify of me going through the last 4 questions, 6, 7, 8, and 9. I'm going to post it. I'm going to record it at 3. I'm going to post it by 3:30. It won't be 30 minutes long though. I'm going to post a screencastify of me going through the rest of these answers. I'm not going to say that it's homework because, I am going to say that it's homework. I need you guys to watch the screencastify of the last 4 problems for this. If you choose not to, you're just not going to be in a very good spot for the assessment tomorrow. Does that make sense? Okay. So what I need from you guys is friends that are here. I'm going to have you grab jackets. We're going to head down for mask break. Question.
If we X out of this rule, save?
Yes, it saves all of your answers if you X out of it, yes. That's the reason that we pay for this program now, instead of with Google Forms where it didn't save. Does anybody, before I head out for my mask break, does anybody at home have any questions? I'm going to be posting a video going through the last 4 at the end of school today. Does anybody have any questions? No questions? Okay, so Aaliyah, that's fine. I just wanted to make sure that I just wanted to see, like, was it your internet or something? Perfect. Thank you for letting me know. I'm going to stop my share. I'm going to put everybody at home in the waiting room because we're going to head outside for our mask break. Give me 30 seconds, guys. Please don't leave the thing, because you're gonna come back in for science in a little bit, please. Okay, so what I'm gonna do is I'm gonna stop this recording.